Hello guys, in this video we're going to prove that the base and the summit of a Saccheri quadrilateral are parallel. Now, if you notice here, we're given some information. We know that angle ACD is 90 degrees. We know that angle BDC is 90 degrees. And we also know that AC is congruent to BD. Okay, so the first thing I'm going to do is I'm going to create some extra information so that we can work this problem out. So the first thing I want to do is I'm going to create, with basic constructions, the midpoints for AB and CD. So I want to create M and Q in such a way that M is in AB such that AM is congruent to BM. Similarly, I'm going to create Q in CD such that CQ is congruent to DQ. Okay, so now we've created the midpoint for the summit and the midpoint for the base. I'm going to want to create a line or construct a line that joins both midpoints and goes through the base and through the summit. And there's a reason for that. So we're going to go ahead and create a line. It's going to look somewhat like that. Okay. And we're going to make use of the inverse of the alternate interior angles theorem. So the theorem says that as long as I have two lines cut by a transversal that create congruent alternate interior angles, both my lines are going to be parallel. Therefore, if we can prove that these two angles are congruent to each other, we're going to prove that the base and the summit are parallel. So we're going to start with this line here. Okay, now that we have line MQ passing through the base and through the summit, the first thing I'm going to prove is that angles AMQ and angle BMQ are congruent. In order to prove this, I'm going to construct line BQ, if I can get it right, BQ, yeah. And then I'm going to construct line AQ, such that this will allow me to prove angle congruency if I'm able to prove that the newly formed triangles are congruent. So first we're going to work with angles with triangles ACQ and triangles BDQ. So let me open another page so that we can see it better. Alright, here we have both triangles highlighted. So using the information that we have, let's prove that triangle ACQ and triangle BDQ are congruent. Well, let's look at the sides first. So we know that AC is congruent to BD because it was given to us. We know that angle ACQ is congruent to angle BDQ because they are both 90-degree angles. And we know, or rather we constructed CQ to be congruent to DQ. Therefore we have CQ congruent to DQ. And because SAS it's an acceptable form, an acceptable proof of congruency, we have that triangle ACQ is congruent to triangle BDQ by side angle side. Okay, now that we have proved that these triangles are congruent, then we can assume by CPC-TC, or corresponding parts of congruent triangles are congruent, that angle AQC and angle BQD are congruent, segment AQ and segment BQ are congruent because they're corresponding, and angle QBD and angle QAC are also congruent. Now that we have all of this new information, we're going to prove that the other two triangles are congruent as well, AMQ and BMQ. So let's move to another page. Okay, here we have triangles AMQ and BMQ highlighted. Let's go ahead and prove their congruency. Well, similarly how we proved that CQ and DQ were congruent by construction, AM and BM are also congruent by construction. So we have that AM is congruent to BM by construction. Then on our previous proof, we proved that AQ and BQ were congruent by CPCTC. So we have that AQ is congruent to BQ by CPCTC. And now we're left with MQ and QM, which are a shared side. So MQ is congruent to QM by the reflexive property. Now because SSS, or side side side, is a valid proof of congruency, we have that triangle AMQ is congruent to triangle BMQ by side, side, side. And again, by CPCTC, we have that angle MAQ and angle MBQ are congruent. Angle AQM and BQM are congruent. And finally, which is what we wanted, angle AMQ and angle BMQ are also congruent. Okay, now that we have established that these two angles are congruent, we can prove by the linear pair theorem that they add up to 180 degrees. So the linear pair theorem says that when two angles form a linear pair, that is, they share the same line and are divided by a transversal, they create a pair of supplementary angles, and therefore they measure 180 degrees. So we have that angle, or rather the measure of angle AMQ plus the measure of angle BMQ is equal to 180 degrees. But because we know that angle AMQ is congruent to angle BMQ, we have that they are both equal to 90 degrees. Now what we have left is to prove that either CQM or DQM are 90 degrees, and we'll be able to prove that the alternate interior angles are indeed congruent, and that will give us a proof that AB and CD, or that the summit and the base of the Saccheri quadrilateral, are parallel. So let me clean this up so we can concentrate on the base angles. Okay, now let's look at the base angles. We already know that the angle CQA is congruent to angle DQB, and we also know that angle AQM is congruent to angle BQM. Perfect. So, by the angle addition postulate, we can say that angle, or the measure of angle CQA plus the measure of angle AQC is equal to the measure of angle CQM. So CQA plus AQM is equal to CQM. Similarly, for the other side, we can say that the measure of angle DQB plus the measure of angle BQM is equal to the measure of angle DQ or angle DQM. Okay, so now let's inspect these angles a bit further. So we know that CQA and DQB are congruent. We also know that AQM and BQM are congruent. Therefore, by the same postulate, the angle addition postulate, we have that the measure of angle CQA plus the measure of angle AQM must be congruent to, you guessed it, and let me write it down here because I don't think I'll have space. So let me rewrite that. So the measure of angle CQA plus the measure of angle AQM is going to be congruent to the measure of angle DQB plus the measure of angle BQM. And now by substitution, we have that CQM, or rather the measure of angle CQM, is congruent to the measure of angle DQM. In the same way, we proved that AMQ and BMQ were 90 degrees angled. We look at the line down here, the base, and this also forms a linear pair of angles. Therefore, the measure of angle CQM plus the measure of angle DQM equals to 180 degrees. 180 degrees by the linear pair theorem. And again, because they are congruent, we can say that CQM congruent to DQM, and they are both 90-degree angles. And if you look at that, we have that, and those are congruent, and this and that are congruent. Well, that satisfies our initial goal, that alternate interior angles are congruent. Therefore, AB must be parallel to CD.